as you probably know, computers, digital systems don't actually have truly random behavior. Yeah, the algorithms that we have are usually called pseudo-random, which means that they generate the needed statistic. Yeah, the data they generate has needed statistics, but they are fully deterministic. We can repeat their sequences. For that, an algorithm usually has a starting number or a seed number as a parameter, and so we can set that number to the certain value, and whenever we start this algorithm with this value, we will get the same sequence. In Supercollider, the language part, which is sclang, yeah, and the SC-synth or the server parts are a bit different. So let's start with sclang. What it has is that the thread class has this run_seed variable, and for the current thread we can access it with this result word and set it to something. And after we've done this, the sequences that we generate with random number generators will have the same results. Yeah, we can see now that these are the same. Yeah. And so on. Now the routine, which is the class that inherits from the thread class, also has that ability, and it's a good practice if we want, for example, some routine to always generate the same sequence that we desire, that we like for some reason. We can specify the certain run seed for that routine, and it will not matter at which point in time, at which point in our code it appears, it will always generate the same results. Because otherwise, let's say we have set this thread to something, yeah, sorry, thread random seed to something, then generated 1, 2, then comes this routine, yeah. We can repeat that without any additional behavior. Yeah, this routine, now you can see, starts with 159. In the first case, also started with the same thing, with all this portion will be repeated. Now, but if we, let's say, put this to 12, for example, yeah, now it will not be repeated because it appears at the later stage. Of course, while being rather simple and very minimalistic way of saving random number calculations, it's not that flexible as, let's say, saving the results of those calculations in a literal form. Yeah, because we cannot easily change something in between the lines. Yeah, and leave all the other stuff as it was. But nevertheless, if we have a certain practices and limit ourselves to certain approaches, this way of saving things is very plausible, and it's good to have a line like this in beginning of your script or anything else. Usually the good way to specify the random seed is with this date. I had it somewhere here. Date. No, not this. Date. Yeah, date seed. It will generate the new seed every time because it's based on the current time of the operating system. Now the server works in a bit different manner. The Supercollider server has its own random number generating mechanism that can be used by the unit generators that need randomness. And most of the unit generators, most of the noises, I guess, use that mechanism. What it allows us to reset their states to the certain value and then repeat the sequence that they were generating by sending the trigger to that internal Supercollider's random number generator. So you can see this example. I took it from the help file. Let's put it like it was in a help file. You can see we have some noise which is filtered with the resonating filter, and the filter frequency is driven by the low frequency noise. Yeah. Now this is one synthesis node. This is the code that launches one synthesis node. Yeah, defines and launches it. And this is totally different one. And now when I start that second one, we see now the sequence gets reset every time when this impulse sends a new one, new trigger to the run seed unit generator. And since the seed value is always the same, so we get the repeating periodic signal out of it. As it's stated in a help file as well, I copied this code here. We can see that the sound of LFO, or the signal of LFO, we don't hear it directly actually, it just drives the filter frequency, doesn't quite follow the triggers. Sometimes it obeys when the trigger comes, but sometimes it says, you go your way, I'm going mine. Why it happens? That's because of how the low frequency noise unit generator is designed. Yeah. So for example, if we will change it for pink noise, you see, yeah, but with the low frequency noise. Yeah, not quite. So what that means is that it depends on the unit generator itself whether it will strictly follow the triggers that were sent from one synthesis node to the server, to the server's random number generator, or not. So it totally depends on how the unit generator is designed. Now we have also in this code, I have this randID statement. Yeah, there's randID in the generator. And this is an important thing. What it means is that actually we have several instances of internal random number generators in Supercollider. And the default number of them is told to be 16 in a help file, but I guess that's just an outdated information, because when I look at the server, in my case it's assigned to S, options num argens, it's 64, and I checked it actually works. Yeah. So I guess the default number is 64, but maybe on some systems the default value will be different. I don't know, but in my case it's like that. So what does it mean that we have different 64 different instances of internal random number generators? That means that we can actually assign our synthesis node and put that into the SynthDef to the certain random number generator. And so in order to reset the state of its stochastic unit generators, we will have to send the trigger to the corresponding random number generator. So we can do that with the rand_id, with the rand_id unit generator. Actually, you can see here it's declared with the IR, initial rate, which means you can only specify it once, but it can also be KR or AR, so control rate or audio rate. Yeah. What happens if we don't specify it at all? That actually means that the current ID will be 0. Yeah, we can check that. Like here, I explicitly told it to work with the random number generator with ID equal to 0, and now here I don't specify anything, and we can see that it works. Yeah, but let's say I put 3 here. Yeah, and now it doesn't have an effect. But if I put 3 here as well, yeah, it works. So that's about the server side. There is a kind of a hack also proposed in the help file of rand_id, or probably rand_seed, I don't quite remember, but the one of those. It's in this help file or in this one. It's proposed that if you actually want to get repeated behavior from the unit generator that doesn't quite obey the triggers that come to the random number generator all the time, you can just restart the synthesis node every time you want its sequence to be repeated. Yeah, for example, this LF noise doesn't quite follow all the triggers that were sent from this synthesis node. I can put this part here, yeah, this part here, remove this impulse, make something like what is that, trig, yeah, put it to like 1, and have this as a control parameter with some default value. Yeah, and then just restart it from the, let's say, routine every time I want the whole sequence to be repeated. If you want more on that, take a look at this help file. And let's, by the way, check where it is. rand_id. Oh, not this. Yeah. Not this one. Probably it's rand_seed without T. Very bad at typing. Yeah, here it is. In rand_seed you can see the examples of it. Like here's that example. Yeah. And then it has fork, which is a method to create a routine from the function, and it just launches it with the fixed interval. With this knowledge in mind, let's proceed to the previous SynthDef that was designed in a previous video. This is a wavetable synthesizer. If you want the details on how it works, just watch the previous video. And what I changed here is just this part, and I want to start with this variant, this one. Now this is the previous configuration with the rand_seed and rand_id specified, yeah, and you can see that I run this, I put this line with rand_seed equal to the seed value specified here before the SynthDef definition, yeah, before this. Why? Because there are some values in this definition, in the function of this SynthDef, that set the default values, for example, for the control signals, yeah, like this one here. If I don't change this parameter later, this one, this control signal, that means that it will always stay at this value. Yeah, so the synthesis node will start with this parameter equal to the value generated by this rand function. And this rand function, if I want to control it with the seed number, should be controlled at this level. Yeah, that's why I put this line here. Yeah. So by having the random seed specified in the SynthDef and the random seed specified for the routine, and this is the same routine that was in the previous video. So what I add this rand seed with the underscore. The underscore means actually rand seed equals to this seed value. So now yeah, and I guess I changed actually the value before. Yeah, 72. Yeah, it's different, but you can see it's repeated. Yeah, now let's go back to this so I will remember what I was dealing with before. Yeah, this is the one I had before. So as you can see, it's a very simple and very important, I would say fundamental method to deal with the randomness and to have an ability to save the results of random calculations while not only making the musical compositions in any language. Actually, it works like in the same manner. And as I said, we can also trigger the...
Папа, а где чай?
Чай? Какой чай?
Ну,
Чай, малышня.
ты
Погоди.
что, его забрал?
Я забрал, да. А ты что хочешь? Ты хочешь чай горячий прям? Он уже остывает же. My assistant. Some technical information. Okay. So what I was after? Yeah. Now we can also change the values on the fly within every synthesis node and have some fancy sequences. Like you can see here, what I use is a demand unit generator, and demand unit generator takes values from so-called demand rate unit generators. These are special type of unit generators in Supercollider which provide a value on demand, or to be more specific, when they receive a trigger. So the impulse here will send the trigger. Once this trigger comes, this demand rate unit generator will calculate some value, and this guy will make a control rate or audio rate signal from it. And in this case I have a e.t.c unit generator which makes a sequence. Yeah, so it has this array, and on the first trigger it will pass this value, then on the second trigger this, then this and this, and when it comes to this last value it will again start with the first one, and so on, because here I have infinite amount of repeats. So let's take a look at it. and so on. You can see also I added this. Let's return to the previous variant. Yeah, it was like this. You can see also I have the seed trigger and seed specified as control signals here. Yeah, seed, trigger, and seed. So I can actually make a sequences of the seed value changes. Yeah, I can have the sequences of the triggers to the synthesis nodes specified here in this routine, and the corresponding sequences of the seed values. And since they are also controlled by the seed number, yeah, I will be able to repeat them as well. So that is the thing I wanted to actually explain and add it to the previous video, but decided to move it to the separate one because it's a kind of fundamental information, and it wouldn't be quite right to put it when a person who watches the video kind of already is into some subject for, I don't know, about an hour. Yeah. Let's add something else, which is that the pattern, and especially the event patterns and the pattern system, can also be controlled with a certain way of specifying a seed number. So there is a p-seed pattern which controls the underlying pattern, which is specified as the second argument, with a certain seed number. And let's put it like this. This is like just my playground. Yeah, let's put it as it is. Here's the p seed and p mono inside. And what p mono does, p mono creates a synthesis node like this, for example. Yeah, one synthesis node, and then does kind of the same thing as done here. It just sets the new values for this synthesis node every time the dur, yeah, this duration passed. Yeah. Yeah, let's put it back. So it just works, the essence is it just works in the same way like the routine before. It works with one synth. Okay, loud guy. Here is one of my ways to do some interesting sequences. So what I do, I restrict the duration of this pattern with the p-fin-dur pattern, which just will free or end the pattern that it has as a second argument with the corresponding duration. And this duration is relative. We can actually scale it with the tempo parameters and all that. Won't dive into that right now. And Pn, what it does, it just repeats the pattern that's specified as its first argument, number of times specified by its second argument. So this is one of the ways I like. And the same thing goes for the p-bind. Yeah, the difference between p-bind and p-mono is that p-bind will create new synthesis node every time the duration the duration ended. Yeah, so since it creates, every time it creates the new synthesis nodes, we should actually have a mechanism to release the previous one. Yeah, so let's return to this previous variant. I like it as well.
Папа, ну что, теплый чай?
Еще нет, радость моя. Sorry, technical. Yeah. So as you can see, lots of different sequences can be generated on the fly with these methods using the pattern library as well. But of course, the key thing that matters is that how actually these random number generators relate to the final subjective estimation of the artistic material that they hear, that the people hear. What actually you want to say with that, or do you want to say with that something? And this is how the language, musical language, is made. Yeah, this is how in time, how you organize the changes to the subjectively meaningful qualities of the sound in time, and it's done through the selection of the parameters in your synthesis design algorithm, and then how you decide to control it in time. Yeah, what's to keep in mind is that the shortness of the sequence generated with random number generator diminishes the differences between different random number distribution functions. That means that the range actually of a much bigger importance now. What I want to say that like from statistics, we know that actually to get the needed statistics from the random number generator, we have to generate a lot of numbers. Yeah, like you want to get that value by dropping the rice to the certain point. Yeah, pieces of rice to a certain point. Yeah, you have to drop a lot in order to get the value. If you just drop 3 or 4 of them, there is no value, so you don't know which function generated this, which statistical distribution function generated this result. Okay, I have my assistants doing some very specific and probably difficult technical tasks, and probably I have to help them a little. So this is all I wanted to say about the randomness. I guess if you didn't know about that, it will open up some new and rather important possibilities for your musical design. The next one, I will talk about the FM synthesis again. There are some topics that I also wanted to address, and I was asked about the cascades, and so probably the next one will be on them. Yeah. Well, I guess I will use them as one of the examples on the subject that I want to talk about. So till next time, see you, cheers.